A bowling ball which has a mass of 5.75 kilograms is moving towards the right with a velocity of 9.5 meters per second when it collides with a stationary bowling pin which has a mass of 850 grams. After the collision, the bowling pin is deflected with a velocity of 11.54 meters per second at an angle of 45.8 degrees below the horizontal. A bit. What will be the final speed of the bowling ball after this collision? B bit. To what angle alpha will be bowling ball be deflected by its collision with the bowling pin? C bit. Is this collision elastic or inelastic? Justify your reasoning with quantitative evidence. Obviously, this numerical is based on collisions, and he is asking us to check whether the collision is elastic or inelastic. So whatever may be the collision, momentum is conserved. Suppose if the collision is elastic, both the momentum and the kinetic energy are conserved. So our aim is to check find out the velocity of the bowling ball, and then the direction, and then we have to check the collision is elastic or inelastic. So let us start with the conservation of momentum. Initially, you see the picture, the bowling ball is moving along the x direction, positive x direction, and then hits the bowling pin, which is stationary. So the entire motion is along the x direction. And after the collision, the bowling ball and the bowling pin move into different directions with different velocities. Okay, so before the collision, we have only x direction momentum, and then after the collision, we have both x direction momentum and y direction momentum. So let us write the momentum. So as we already discussed, momentum is conserved. Let us write the momentum along the x direction and y direction. Now, what is the x direction momentum? Momentum before collision is equal to momentum after collision. So m1v1x plus m2v2x is equal to m1v1x dash plus m2v2x dash. Okay. So what is the mass of the bowling ball? 5.75 kilograms, and then the velocity is 9.5 meters per second. Similarly, the mass of the bowling pin is 850 grams. That means 0.850 kilograms. And then the initially it is at rest. Therefore, the velocity is equal to 0. Okay. And then after the collision, we have to find out the velocity of the bowling ball and also the direction. And after the collision, the velocity of the bowling pin is 11.54 meters per second, and then the direction is 45.8 degrees with the horizontal. Now let us write the x direction momentum. So m1v1x plus m2v2x is 5.75 times 9.5 plus 0, because the bowling pin is at rest, is equal to momentum after the collision along the x direction. So m1v1x dash. So 5.75 is the mass of the bowling ball, and then v1x dash we have to find out. And then m2v2x dash, that is given to us. That means 0.8 mass of the bowling pin is 0.85 kilograms, and then the velocity is 11.54 meters per second, and then the angle is 45.8 degrees. He gave the angle also, 45.8 degrees. Beta is given to us. So this becomes the x direction. So x direction is the adjacent side to this one. Therefore, the value is cos value. We have to take the cos component, and moreover, it is along the positive x direction. Therefore, the numbers are positive. Okay. Now, after plugging in these values and then calculating, we will get the velocity of the bowling ball after the collision is equal to, along the x direction, is 8.31 meters per second. Okay. Similarly, we have to write the y direction momentum also. So m1v1y plus m2v2y is equal to m1v1y dash plus m2v2y dash. Initially, both the balls are moving along the x direction. Therefore, there is no y direction momentum, therefore 0. And then after the collision, they are moving in two different directions along the along the y direction also. Therefore, we have to consider that one. And then here beta is, that means is a bowling pin direction is given to us. And then here m1 v1 y dash. So we have to find out v1 y dash also, because that is not known to us. And then v2 y dash is given to us. That is actually v2 dash is given to us. That is 11.54. And then the direction is negative, because this is the bowling pin is moving in the downward direction. Am I right? So this is the downward direction, means we have to put the negative sign. Okay. When we put the negative sign, it will be sine minus 45.8 degrees. So the answer will be v1 y dash is equal to 1.22 meters per second. Okay, so using these two values, 8.31 and then 1.22, we have to find out the velocity of the bowling ball. So velocity of the bowling ball v1 dash is equal to square root of v1 x dash square plus v1 y dash square. So plug in the values, you will get v1 dash is equal to 8.4 meters per second. This is the velocity of the bowling ball after the collision. Now we have to find out the direction. We know tan alpha is equal to y by x. So y direction velocity divided by x direction velocity after the collision we have to take. Therefore, tan alpha is equal to 1.22 divided by 8.31 gives the value, and then alpha is equal to tan inverse this value gives 8.35 degrees. Now we have to check whether the collision is elastic or inelastic. So for that, what we have to do is, now we checked the momentum. Now we have to check the kinetic energy. So kinetic energy before collision is equal, if the kinetic energy before collision is equal to kinetic energy after the collision, then the collision is elastic. So for that, let us write the kinetic energy before collision. Kinetic energy before collision is equal to half m1 v1 square plus half m2 v2 square. So plug in the values here. We have v2 is equal to 0, because the second bowling pin is at rest initially. Therefore, we will not get any kinetic energy for the second ball. Only first ball has the kinetic energy. Bowling ball has the kinetic energy. That is 259.46 joules. Now let us calculate the final kinetic energy. Final kinetic energy is equal to half m1 v1 dash square plus half m2 v2 dash square. So plug in the values here. We just now we calculated v1 dash is equal to 8.4 meters per second, and then v2 dash is given to us as 11.54 meters per second, and then masses are 5.75 bowling ball mass, and then 0.850 is the mass of the bowling pin. And then after plugging in the values in the equation, we will get the answer as 259.46. So there is a perfect match of the energies. There is no loss of energy. Therefore, the collision is elastic, because both momentum and kinetic energy are conserved. The collision is elastic. Okay. He asked us to prove with quantitatively. So therefore, the values are perfectly matching. The energy values are matching, and then the momentum is also matching. So we need not. We will conclude that the collision is an elastic collision. It is not inelastic, elastic. This collision is elastic. Okay. Hope this helps. Thank you. Bye bye.